In this video, I will show you how to solve exponential and logarithmic equations such as this one. We may need one of these exponent tables as we go along, so come prepared. The key is to rewrite the equation so that both parts have the same base. So for example, 4 can be written as 2 to the second power, and 8 can be written as 2 to the third power. The x plus 7 goes in parentheses, as does the x plus 3. If the bases are equal, the exponents have to be equal. So I'm going to set these exponents equal to each other. I hope you don't mind if I go ahead and do the distributive property as I go. I hate to skip steps, but come on. So this will be 2x plus 14 is equal to 3x plus 9. And suddenly we're back in Algebra 1. So let's get these x's together by subtracting. So that's negative x plus 14 is equal to 9. And let's subtract 14 from both sides. What's that? So x equals 5. Number 2 is very similar. Obviously, we will go with a base 7. So 49 can be written as 7 squared. And then you have x plus 4. And then we'll just keep the 7 to the 18 minus x power. If the bases are equal, the exponents have to be equal. So that means 2x plus 8 will equal 18 minus x. So let's get those x's together by adding x to both sides. So that'll be 3x plus 8 is equal to 18 minus 8 on both sides. So that'll give me 3x is equal to 10. So x is equal to 10 over 3. All right, looking at 9/16. You will probably believe me if I tell you that 9 over 16 is the same thing as 3/4 squared. Right? Because if you squared 3 and you squared 4, you would get 9 over 16. All right, so that's the same thing. And I will just take my 3x minus 2 and put that in parentheses. So again, if the bases are the same, the exponents must be the same. So this is going to be 6x minus 4 is equal to 5x plus 4. So subtract 5x from both sides. That'll give you x minus 4 is equal to 4. If you add 4 to both sides, you get x equals 8. All right, for number 4, we're starting off in logarithm form. We're going to have to change the form in order to solve this. Remember that natural log is the same thing as log base e, but the base e is understood. So if we rewrite this in exponent form, it would be e to the 4th power is equal to a. And that's it. So a is equal to e to the 4th power. For number 5, you need to recognize that you can't take the log of a negative number. So this is going to be no solution. For number 6, we have to do a couple Algebra 1 steps first. Subtract 14 from both sides. So this is going to give me 20 natural log 7x is equal to 40. Divide both sides by 20. So that'll give me natural log 7x is equal to 2. So that's the end of our Algebra 1 steps. So remember, natural log is the same thing as log base e of 7x. So we need to rewrite this in exponential form. So this would be e to the second power is equal to 7x. So we need to do one more step to get x by itself. We need to divide both sides by 7. Okay, so those would cancel out. So the final answer is x equals e squared over 7. Okay, for number 7, first we need to take care of the Algebra 1 step and divide both sides by 12,000. Alright, so these will cancel each other out. So this is going to give me log base 2 of k equals, did anybody already do this? How many times does 12 go into 16? So I'll go ahead and rewrite this in exponential form. So this would be 2 to the 16 power is equal to k. And I will definitely just leave it like this. All right, on number 8, if the log and the base part is equal, the argument of the log, the stuff inside the log, has to also be equal. So logic dictates that x squared plus 5 must equal 41. So subtracting 5 from both sides, we're going to get x squared is equal to 36. Taking the square root of both sides, x is equal to plus or minus 6. Now we have to be careful. You can't take the log of a negative number. So especially the negative 6, you just have to be careful about it. In this case, can you see why negative 6 will be okay? Once you square it, it's going to become a positive 36, so it's okay. If this had not been squared, if all I had was x plus 5, negative 6 would be an extraneous value. But as it is, both of these are okay. For number 9, before we can set things equal to each other, we need to condense this part. According to the product rule, when you have the sum of two logs, you can condense that to a single log using multiplication. So this will condense to log base 7 of, and then I'd have 9 times x minus 4. So that means log base 7 of 6x is equal to log base 7 of 9x minus 36. So if the log and base is equal to the log and base, the argument must be equal. The stuff inside the logarithm must be equal. So 6x must equal 9x minus 36. So subtracting 9x from both sides, that's going to give me negative 3x is equal to negative 36. And then dividing both sides by negative 3 is going to give me x equals 12. Okay, I'm just taking a quick look to make sure that I'm not going to get any negative numbers if I plug 12 back in. And it looks like 12 will work fine. Again, on number 10, we need to condense the right-hand side before we proceed. When you have when you have the difference of two logs, you can condense using the quotient rule, which says that you'll make a fraction out of it. This would be the same thing as log base 11 of x plus 5 over 2. All right, that's your quotient rule. So now that we have the log base 11 on both sides, the argument, the stuff inside the logarithm, must be equal. So 3x must equal x plus 5 over 2. All right, so we are obviously not liking the fraction. So we're going to want to multiply both sides by 2 to get rid of the fraction. So that's going to give us x plus 5 over here and 6x over here. So now if we subtract x from both sides, we have 5x is equal to 5. If we divide both sides by 5, we get x equals 1. For number 11, there's no Algebra 1 stuff to do. We immediately need to rewrite this in log form. Start with the base, log base 6. The other two parts are going to change sides. So the 28 comes over here, and the x minus 1 goes over there. To get x by itself, of course, we will add 1 to both sides. So that gives us a log base 6 of 28 plus 1 is equal to x. That's as far as we can go without a calculator, but we can type all this into the calculator. Depending on what kind of calculator you're using, you may need to use the change of base formula to rewrite this part of it. So we could rewrite this as log 28 over log 6. All right, if you don't have the type of calculator where you can just type in a logarithm with its base directly. Most scientific calculators, you could do this. So that's what I'm going to do on my TI-30XS multi-view. You could go into fraction mode and type in log 28 over log 6. And then plus 1. Okay, so 2.8597. For number 12, first we need to add 1 to both sides. So that's going to give us 8 to the x power is equal to 4.4. Now we will rewrite this in log form. So log base 8, these two parts will switch sides, so the 4.4 goes over here and the x goes over there. Again, depending on what kind of calculator you have, you may need to rewrite this using the change of base formula. So in this case, you could write this as log 4.4 over log over log 8. Okay, so let's see what that is. Okay, 0.7125. And finally, for number 13, first we need to subtract 5 from both sides. So that will give us e to the 2x power is equal to 11. And if I were just blindly following the normal pattern, I would say log base e, and then I would switch these two parts. So I'd have log base e of 11 is equal to 2x. But we don't write log base e. Instead, we write natural log, log natural, without the base e showing. It's understood. So natural log 11 is equal to 2x. And then, of course, to get x by itself, we will need to divide both sides by 2. Okay, so natural log of 11 divided by 2. Whoops, wrong button. Let's see what that is. Natural log 11 divided by 2. 1.1989. That was a good year for me. I was in college, University of Maryland. Good times. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.